This tutorial is part of the course I took this year at Skoltech called Learning How to Learn Python Online. In this course, we have created our own courseware and taught it to other students and also evaluated them. And this course resulted in a final project, which I'm going to present here and also teach you how to use it. The topic of this mini lecture is uh, serial communication uh, between Python and Arduino. Uh, if you don't know, Arduino is a type of a microcontroller, a physical computing platform available for everyone to buy and implement, and you can read more about it at arduino.cc. You can buy the boards and also download the software to build your own physical prototypes and devices. Uh, so as I said, serial communication is a way of your computer communicating with your Arduino using a serial port. It could be physically a USB port or a COM port in older computers. So the challenge is, how would you create a serial connection uh, with a communication protocol to ensure that your data gets delivered, that your data transferred between Arduino and Python gets packaged and transferred well. So in order to do that, uh, I wrote a library which is freely available at GitHub. You can go there and download it freely. It's a library for both Python and Arduino. So in order to deploy it and implement it, go to github.com/androdichenko. That's my GitHub, and then you can go to Simple Serial Protocol, and there are two folders, Arduino and Python 3. The Arduino is the serial connection implementation for Arduino platform, and Python 3 is its counterpart for the Python 3 uh, platform. So let's download both of them. Let's download zip, and we'll have it downloaded to the desktop. Okay, let's download it. Let's unpack it. Uh, okay, extraction complete, and here you have it. Simple serial protocol master. Uh, in this folder, you can also find the communication with devices via Python, IPYNB. This is an IPython file that has some description of the workings of the protocol and why do you need it in general. And you can view it with any IPython uh, viewer. If you type IPython in Google, you can go to IPython and then through this IPython framework view this file. So without further ado, let's jump into implementing and coding. First, let's go to Python 3 and set everything up in Python. So we have two files here, serial protocol class.py. This is the class that's responsible for all the communications, and serial protocol example.py. Let's open it in Sublime, which I'm using at the moment. And there is an example on how to use it. The main functions of these serial communication framework that I implemented either is mm, callback mechanism. So when anything happens in when you receive any kind of messages, you get your callback function gets called. You can also define your own commands uh, that are being translated into numbers and then sent by serial port. And you can also connect to any serial device you already have. So in order to create the simplest implementation, let me just start a new file and start implementing. So first we need some imports for Python 3. I'll call this file example.py. Then, of course, we have to import our own class for serial connection. Then, first of all, let's figure out what commands are going to be sent between our Arduino and our Python script. So let's create a new list, a new tuple of tuples. The structure is as follows. Let's leave the heartbeat, and let's also create another command called cmd without cd, just my command, with a number of 2. Number is just the number that stands for this command during serial communication, and the only limitation is that all of those numbers in your commands that you define have to be different. So if both are zeros, it doesn't work. You gotta have different numbers. Okay, then if you're familiar with serial connection with Python in general, this serial protocol connection is opened the same way with a with construct in Python, and what it does is it ensures that your connection gets closed properly if something goes wrong in your program. So you see the simple protocol connection constructor has several parameters, and the first one is port, and if you're on Mac OS like I am right now, you can go to terminal and check all your serial ports available at the moment by executing ls dev, and here you go, you have all your potential devices, and among them you can find an Arduino that you have connected before that. Yeah, it's going to be something like tty.usb modem, and then some numbers like 1411 or so. So let's say our Arduino is TTY USB modem 1411, and let's define a port. So for my macOS system is going to be dev TTY USB modem 1411. Baud rate. The baud rate ranges from anything from 9600 to 159,200 kilobits per second. So for our example, we're going to take the baud rate as 9600, and you have to remember this and set the same value in your Arduino code. Then comments. We have already defined our set of comments, and then the last argument is whether we want to debug this. Obviously, you don't want to do this, so set debug to false. Okay, as connection now, con holds our connection after this line. Okay, so now let's do something. Let's start at this point. When you did with simple protocol connection, it's already communicating with your Arduino, and by this point you have to have your Arduino connected and your code uploaded to Arduino. So let's start up Arduino, and I'll show you how to load the code. If you're not familiar with Arduino, there's a lot of good examples and good tutorials on Arduino. So anyway, so let's open the simple serial connection example. And in order for it to work, we have to copy the includes into our newly created sketch. Okay. So my Arduino is dying for some reason. Got it. So let's create a new sketch in Arduino. And Arduino.cc holds a lot of examples of how you can do it and what you can do with Arduino. Let's first save it and call it. Okay. I want to save it on my desktop. Users desktop. We're gonna call it example Arduino. Let's save it. Okay, we got it. So now I have to go to includes that you have downloaded. It's in the folder you download. Copy 2 items and paste them into your new sketch folder. You have to do it. Sorry, wrong button. You have to do it because then, if you don't do it, the Arduino won't see the library, the simple serial protocol library that we have. Okay, close Arduino and now reopen it. And you will see if everything went good. Then you will see 2 more tabs here that represent the library for serial communication. Okay, using library is quite simple, somewhat similar to Python library. It handles everything for you, so I'll just open the simple serial example and copy and paste from it. So first of all, of course, we have to include our library first place. Then we have to create a simple serial protocol. So what the simple serial protocol construction does, it creates an object P as simple serial connection, and the arguments are the serial, which serial you want to use. If you're using Arduino Uno, the most abundant Arduino, then this argument is going to be serial, just like written here. Otherwise, if you're using other boards, you pretty sure know what you're doing, so it's going to be serial 1 or serial 2 on Arduino Mega. And also an evaluate message. This evaluate message is the name of the function that is going to be called every time some message arrives from Python, from our Python code. Let's define this function right away. I'll just copy and paste it here. So this function is going to be called every time a message from Python arrives, and the arguments of this function are going to be cmd, the received comment, and value, the received value. Okay, now let's set something more up. So first of all, you gotta obviously have serial begin, and I told you to remember the baud rate you're using for Python. You're gonna have to put the same baud rate here. In this case, it's 9 to 600. Well, also, you want to be able to receive messages. So for this example, on every loop iteration, we're just going to be receiving messages from our simple serial protocol. So, and that's pretty much it. This is your simplest code. What it does, it constantly receives messages from the Python code and sends back a pcmd-ack comment, which is the default acknowledgement comment. The library sees this comment as an acknowledgement that the comment has been received. The previous comment has been received. So it's a good way to verify that your Arduino indeed received the message from your Python code. If you want to go more in depth, you can play around with a simple serial protocol example, which has some timers set up, but I won't go into detail of that. It's a whole different tutorial. But anyway, now you have 2 files. Set up your example py and your example Arduino. You can flash your Arduino with this example, and you can run this py file, this Python file, to communicate with Arduino. So right now we're not sending anything from the Python file, as you can see, so nothing is going to be happening. So let's start uh, you know, sending something every 4 seconds. Some some comment that we define. So okay, we have this send comment, and let's send my comment with a value of 1, 2, 3 every 4 seconds. So it's going to be time dot sleep, and we also have a perpetual loop. Okay, so let's run it. It has inconsistent tabs, unfortunately, somewhere. This happens for me in Sublime at some point, so I should be working. Okay, so yeah, so the problem is that there's no Arduino connected. I don't have an Arduino, unfortunately, at the moment because we run out of them in our laboratory. We're only going to be buying more of them next calendar year, and maybe I'll be able to make another tutorial. But this illustrates how you can use simple serial connection, play around with it, look at the examples, and hopefully you'll be able to send data between your Python code and Arduino code back and forth. Thank you again. I appreciate that you're watching this. Maybe you find helpful. Uh, if you're confused or if you want to know more, just shoot me an email at nikita.rodichenko at skoltech.ru, uh, and hopefully I'll be able to answer your questions and help you implement this in your code. Well, we'll see. It's open source, so feel free to use it. The license is defined. Okay, so thank